Let's do some problems on these concepts. Zeros of a polynomial, remainder theorem and factor theorem. First one. Find the value of the polynomial 7x squared minus 5x plus 3 when x is equal to 0, x is equal to minus 1, x is equal to 2. So let's say this polynomial is p of x, 7x squared minus 5x plus 3. We have to find the value of this polynomial when x is equal to 0 for the first one. So we use the method of substitution. We put 0 wherever we find x in that polynomial. So we denote that by p of 0. That is equal to 7 into 0 square minus 5 into 0 plus 3. So this and this will go away because those two terms will be 0. This is equal to 3. Next one is p of minus 1. I have to find the value of the polynomial when x is equal to minus 1, which I denote by p of minus 1. So that is equal to 7 into minus 1 whole square minus 5 into minus 1 plus 3. That is equal to 7 into minus 1 whole square is 7. Minus 5 into minus 1, that is plus 5 plus 3. So that is equal to 15. Next one is I have to find the value of the polynomial when x is equal to 2, which I denote by p of 2. So that is 7 into 2 square minus 5 into 2 plus 3. That is equal to 28 minus 10 plus 3. That would be 18 plus 3, 21. Next one. Find p of 0, p of 1, p of minus 1 for the polynomials. P of x is equal to x square minus 3x plus 1 and p of t equal to t minus 1 into t minus 2 into t minus 3. First one, the polynomial given is x square minus 3x plus 1. I have to find p of 0 for this. That is 0 square minus 3 into 0 plus 1, which is equal to 1. And p of 1 for this polynomial will be 1 square minus 3 into 1 plus 1, which is 1 square is 1 minus 3 plus 1. 2 minus 3 is minus 1. Next one is p minus 1. That is minus 1 whole square minus 3 into minus 1 plus 1. That is 1 plus 3 plus 1. That is 5. For the next one, I have to find the value of this polynomial p of t when t is 0, 1 and minus 1. Let's calculate first p of 0 for the second one. I put 0 wherever I see t in that polynomial. 0 minus 1 into 0 minus 2 into 0 minus 3. Observe that that's a cubic polynomial. T into t into t. So that gives us a highest power as 3. So it's a cubic polynomial. This will be minus 1 into minus 2 into minus 3. That gives me minus 6. Similarly, p of 1. That is equal to 1 minus 1 into 1 minus 2 into 1 minus 3. This 1 minus 1 will be 0. So 0 into everything else will become 0. So I don't have to calculate the remaining part. So p of minus 1 is the next one. Minus 1 minus 1 minus 1 minus 2 into minus 1 minus 3. That is equal to minus 2 into minus 3 into minus 4. That is equal to 24 with a minus in front. Third one, find the zeros of the polynomials. What is the zero of the polynomial? The zero of a polynomial is the value of the variable that makes the entire polynomial's value 0. So for the first polynomial, p of x is given as cx plus d, where c and d are real numbers. I have to find the value of this x that will make this entire polynomial's value 0. So the technique here is to set this polynomial p of x to 0 and solve that equation to find the value of x. So I'll say cx plus d is equal to 0. That implies cx is equal to minus d. That implies x is equal to minus t by c. So this is the value of the variable that makes this entire polynomial's value 0. Second one is p of x is equal to x plus 5. Same technique, that p of x is equal to 0, that is x plus 5 is equal to 0. That means x is equal to minus 5. So minus 5 is the 0 of this polynomial x plus 5. Similarly, for p of x is equal to 4x minus 7, I will set this polynomial to 0 to find the 0 of that polynomial. 4x minus 7 is equal to 0. That implies 4x is equal to 7 and x is equal to 7 by 4. That is the 0 of this polynomial. Next one, find the remainders when 3x cube minus 4x square plus 7x minus 5 is divided by x minus 3 and x plus 5. The polynomial, let that be denoted by p of x, is equal to 3x cube minus 4x square plus 7x minus 5. And the divisor, in the first case, the divisor is x minus 3. So the divisor is x minus 3. What is the 0 of this divisor? 0 of divisor polynomial is equal to 3. Therefore, the remainder when p of x is divided by x minus 3 is what? It gives a remainder of p of this 3. P of 3. So I have to find p of 3 for this polynomial, and that will be the remainder when I divide that polynomial by x minus 3. So p of 3 will be what? That is equal to 3 into 3 cube minus 4 into 3 square plus 7 into 3 minus 5. So this will be 27 into 3, 81 minus 36 plus 21 minus 5. So this will be 102 minus 41. That is equal to 61. Similarly, I can find the remainder when this polynomial is divided by x plus 5. The 0 for x plus 5 is what? Minus 5. So I have to find p of minus 5, and that will be the remainder when this polynomial is divided by x plus 5. Let's find p of minus 5. 3 into minus 5 whole cube minus 4 into minus 5 whole square plus 7 into minus 5 minus 5. That will be 3 into minus 3. Minus, this minus comes to the front because this is an odd power. Minus 3 into 125 minus 4 into 25 minus 35 minus 5. So this will be minus 375 minus 100 minus 40. So this will be minus 475 515. Okay. So that is the remainder when you divide that polynomial by x plus 5. Next one is the fifth one. The polynomials kx cube plus 3x square minus 8 and 3x cube minus 5x plus 8 are divided by x plus 2. If the remainder in each case is the same, find the value of k. So let's denote these polynomials by p of x is equal to kx cube plus 3x square minus 8, and the second polynomial by q of x, which is 3x cube minus 5x plus 8. So the remainder when p of x is divided by x plus 2 will be p of minus 2, and the remainder when q of x is divided by x plus 2 is q of minus 2. The question says these two are the same. So I have an equation. I equate p of minus 2 to q of minus 2. I should be able to solve for the value of k. So p of minus 2 is what? I substitute minus 2 in this polynomial, and q of minus 2 I get by substituting minus 2 in this polynomial wherever I see x. So let's find p of minus 2 and q of minus 2 and equate. K into minus 2 whole cube plus 3 into minus 2 whole square minus 8. That is equal to 3 into minus 2 whole cube minus 5 into minus 2 plus 8. So that implies minus 8k plus 12 minus 8 is equal to minus 8 minus 24 plus 10 plus 8. So that implies minus 8k plus 4 is equal to minus 24 plus 18 minus 6. That is minus 8k is equal to minus 10. That implies k is equal to minus 10 by minus 8. That is equal to 5 by 4. That is the value of k. Next one, sixth one. Find the values of a and b so that x plus 1 and x minus 1 are factors of this polynomial. Let's say this polynomial is p of x. So p of x is equal to x power 4 plus ax cube minus 3x square plus 2x plus b. Given that x plus 1 and x minus 1 are factors of this polynomial, it means that when I divide this entire polynomial by x plus 1 or x minus 1, I get a remainder of 0. So what are the remainders when I divide this polynomial by x plus 1 and x minus 1? The remainders are p of minus 1 and p of 1. Because for x plus 1, the 0 of this polynomial is minus 1. For x minus 1, the 0 of this polynomial is 1. So if I calculate p of minus 1, I get the remainder. If I calculate p of 1, I get the remainder when I divide that polynomial by x minus 1. But given that those two are factors, so I can equate these two to 0, right? So let me erase this. So let's calculate p of minus 1. That will be minus 1 whole power 4 plus a into minus 1 whole cube minus 3 into minus 1 whole square plus 2 into minus 1 plus b, that is equal to 0. This will give me my first equation. That will be 1 minus a minus 3 minus 2 plus b is equal to 0. So this will be minus a plus b. So this will be 1 minus 5 minus 4. It will go to the other side and become 4. So this is my first equation. Second one is p of 1 is equal to 0. If I equate p of, this is for this one, and I'll calculate p of 1 now. P of 1 is equal to 0 means 1 power 4 plus a into 1 cube minus 3 into 1 square plus 2 into 1 plus b is equal to 0. 1 plus a minus 3 plus 2 plus b is equal to 0. This will give me a plus b is equal to 0. This is my second equation. If I add 1 into 1 plus 2 will give me what? It means I add LHS of both the equations and equate to the sum of the RHSs of both the equations. What I get is 2b is equal to 4 plus 0, that is 4. That implies b is equal to 2. This means a is equal to minus of b from the second equation. Therefore, a is equal to minus 2. These are the values of a and b. Next, use factor theorem to verify that x plus a is a factor of x power n plus a power n. What is the polynomial given? This is for the seventh one. P of x is equal to x power n plus a power n. This when divided by plus a, the remainder is p of minus a. I have to verify that this x plus a is a factor of this, which means that I have to prove this p of minus a is equal to 0. If I prove p of minus a is equal to 0, which means the remainder is equal to 0, then I would have proved that x plus a is a factor of p of x. Let's calculate p of minus a. P of minus a is, I substitute minus a in that polynomial wherever I see x. That is minus a power n plus a power n. What is this equal to? We know from the rules of our exponents, minus x power n is equal to x power n if n is even, and minus x power n if n is odd. This is something that we know from exponents rules. So this will become minus a power n because problem says n is an odd positive integer. So this is the rule that applies here when n is odd. Plus a power n. So these two get cancelled and this becomes 0. Therefore, we can say that x plus a is a factor of x power n plus a power n because the remainder is 0. Next one. Factorize. P of x is equal to x cube minus 2x square minus 5x plus c. We have to factorize this polynomial using factor theorem. Let's try out some values. I don't have to try p of 0 because if this goes away, I still have 6, so it's not giving me a value of 0. I'll try p of 1 first. If p of 1 comes out to be 0, then I can say x minus 1 is a factor. Let's see whether it's 0 or not. 1 cube minus 2 into 1 square is minus 2 minus 5 plus 6. This will give me what? 6 plus 1 is 7. 7 minus 7, 0. So I can say x minus 1 is a factor. Now let's calculate p of minus 1. Minus 1 whole cube minus 2 into minus 1 whole square minus 5 into minus 1 plus 6. This is minus 1. This is minus 2. This is plus 5. This is plus 6. This is not equal to 0. So x plus 1 is not a factor of that polynomial. Let's calculate p of 2. 2 cube minus 2 into 2 square minus 5 into 2 plus 6. This 8 and this 8 will get cancelled. This is not equal to 0. So x minus 2 is not a factor. Let's calculate p of minus 2. Minus 2 whole cube minus 2 into minus 2 whole square minus 5 into minus 2 plus 6. This is minus 8. This is also minus 8. This is plus 10. This is plus 6. This is minus 16 plus 16. This is 0. Therefore, x plus 2 is a factor. Right? Let's calculate p of 3 and see. 3 cube is 27 minus 3 square into 2 minus 18 minus 5 into 3 minus 15 plus 6. These two will give me 33 and 27 plus 6, 33. So this is equal to 0. 33 minus 33 is 0. Therefore, I can say x minus 3 is also a factor of that polynomial. Therefore, I can write p of x is equal to product of all the three factors. X minus 1 into x plus 2 into x minus 3. This polynomial p of x is a cubic polynomial and hence it will have three factors. If it's a quadratic polynomial, it will have two factors. Ninth one. Without actual division, prove that this polynomial is exactly divisible by x square plus 2x minus 3. What is the divisor? Polynomial divisor is x square plus 2x minus 3. So that is, if you factorize this, it will come out to be x minus 3 into x minus 1. Okay, I'll have to put a plus here. So the factors of this polynomial are x plus 3 into x minus 1. So if I can prove that this x plus 3 is a factor of that polynomial and this is also a factor of x minus 1 is also a factor of that polynomial, I would have proved that this is a factor of that polynomial. For proving that x plus 3 is a factor, I have to prove that p of minus 3 is equal to 0. And for proving x minus 1 is a factor, I have to prove that p of 1 is also equal to 0. The remainders are 0. So let's see whether p of minus 3 is 0 or not. P of minus 3 is equal to minus 3 power 4 plus 2 into minus 3 whole cube minus 2 into minus 3 whole square plus 2 into minus 3 minus 3. So this is what? 81 minus 54 minus 18 minus 6 minus 3. So this is 81 minus all these added together clearly is minus 81. So this is equal to 0. So x plus 3 is a factor of that polynomial. Let's also check out p of 1 now to prove that x minus 1 is also a factor. That will be 1 power 4 plus 2 into 1 cube minus 2 into 1 square plus 2 into 1, 2 minus 3. That is equal to 1 plus 2 minus 2 plus 2 minus 3. This is equal to, this will get cancelled, 3 minus 3, 0. So x minus 1 is also a factor. So this is a factor of the given polynomial. This is also a factor of the given polynomial. But the product of these two factors is this. Therefore, I can say that this is also a factor of the given polynomial. Therefore, x square plus 2x minus 3 is a factor of p of x. A 10th one. P of x is equal to x power 4 minus a square x square plus 3a minus a. Given that x plus a is a factor of this, x plus a is the divisor, the 0 of x plus a is minus a. Given that x plus a is a factor, it means that when I divide p of x by x plus a, the remainder that I get is p of minus a. This is equal to 0. This is given because it's a factor. This is a factor of this, means that the remainder p of minus a will be equal to 0. Let's calculate p of minus a and set it to 0. So substitute minus a wherever I see x in that polynomial. That means minus a power 4 minus a square into minus a whole square plus 3a minus a is 2a, that is equal to 0. This will be a power 4 minus a square into minus a whole square is a power 4 again, plus 2a is equal to 0. This will get cancelled, these two will get cancelled. 2a is equal to 0, that implies a is equal to 0. This is the value of a if x plus a is a factor of that given polynomial.